Now we are going to learn training session 1. In this training session, we are going to learn detailed engineering on workpiece plate. After this session, what we are going to know: details of workpiece plate, types of workpiece plate with their specific use. In third, technical requirement for selection of workpiece plate. In fourth, different type of tapping details. Fifth, straight length requirement needed in upstream and downstream of workpiece plate. Flange rating in workpiece plate. Calculation for workpiece plate. Analysis for curve between flow versus differential pressure, flow versus delta P, and PPL versus flow. This 9 things we are going to learn in this session. You have complete knowledge of these things after completion of this session. First one, details of workpiece plate. This is the metal disc with the hole in it. It is inserted in the fluid flowing line to drop the fluid velocity. How will you work this plate? This will be metal disc and one hole will be inside it. What it does, this hole reduces the fluid velocity. This velocity drops result in change in the pressure. This velocity drop will result in change in the pressure. With this change in pressure, we can measure the flow from the delta P. So this is the one type of formula for the measurement of the flow. See how workpiece plate look like. This is the workpiece plate, and we take this workpiece plate and put in the pipeline. And this pipeline, we will take the tappings from the workpiece plates, and with this tapping, we will insert here one flow transmitter. So now we have detailed knowledge of workpiece plate. What workpiece plate does? It does the what workpiece plate is doing. It is reducing the velocity. With this reduced velocity, we are generating delta P. With this delta P, we are measuring the flow. Now types of workpiece plate. Second topic of this training session. These are the type of workpiece plate: concentric, eccentric, segmental. How it look like? Concentric, hole will be in the center. Eccentric, hole will be here, or hole will be here. So a hole will be not in the center. As segmental hole will be like this. So these are the three types of workpiece plate. There are many types of another workpiece plate also, but here we are only discussing which are mostly used. Now we are one by one we will learn in detail. Concentric workpiece plate. This is the concentric workpiece plate. Here hole in the center. In the workpiece plate, all detail is written. What is the inlet, and these details are written. We will learn in data sheet of the workpiece plate. There we will learn what is the use of this. As shown in this type of workpiece plate, hole should be in the center. Now eccentric type workpiece plate. In this type workpiece plate, hole will be off center. Off center means it will be not in the center. So this is the eccentric type workpiece plate. Eccentric type workpiece plate are used for liquid that contain the gases or solids. This is the use of eccentric type workpiece plates. Now segmental workpiece plate. This is the segmental workpiece plate. Segment means part of anything. So here segment is a part of hole. So it hole will be not complete. It will be part of hole. That is the only difference. As the name suggests, in this orifice plate, hole is not circular but is the segment of full circle. It is used where fluid contain more impurities and is also used in slurries application. So this is the you have to remember where we are going to use this type of orifice plate. This type of orifice plate we are going to use where more impurity is in the fluid and slurry applications. From here, complete detail engineering will be started. Till now, we have covered the basics of orifice plate that already we have covered in the practical training session. Those people who have not purchased practical training session, they also can see there or they can see these lectures also. We have given the equivalent knowledge here also. What are the technical requirement? First one is the beta ratio. Second one is state length requirement. Then we will learn the tapping. Then we will learn the orifice sizing standard. What are the standard we follow for the orifice sizing? Then we will learn the flange rating. Then we will learn the vena contacta. What is the vena contacta? Then we will learn what is the pressure drop. Pressure drop is very essential when we are installing the orifice plate. Because of orifice plate, there will be pressure drop. Plate materials. What are the material we use for the construction of orifice plate? Assembly materials. These things we will learn. Now we are going to see beta ratio. Beta ratio defined as the ratio between bore diameter of flow restriction like orifice and flow nozzle and the inside diameter of the pipe. Suppose any pipe is there, its diameter inside diameter is 200 mm and we are installing one orifice plate here. Its bore size is 20 mm. Then what will be beta ratio? 20 mm by 200 mm. This will be the beta ratio that only written here. Beta ratio of concentric type orifice plate. This I am saying that this is not a hard and fast rule. We are just giving the general idea. Beta ratio. What is the beta ratio value? For liquid case it will be the 0.50 to 0.75. For gas and steam it will be 0.20 to 0.70. For good result, beta ratio should be in the range of 0.4 to 0.6. Many places it will be written as a 0.2 to 0.75 like that. So these are general idea I am providing here. Many places it will be written what is a good range of orifice plate and it will be written 0.4 to 0.75. For different case, the beta ratio will be different. Then what is the relation between beta ratio and differential pressure? When beta ratio is low, differential pressure created by orifice plate will be high and vice versa. So it means our beta ratio is inversely proportional to delta P. When we are going to measure, suppose we are some flowing inside this and we want to measure this flow. Then for flow we need the specific of delta P. Specific delta P we need. Suppose here 10 ton per hour flow is there, then we need fixed amount of delta P for 10 ton per hour. In future you will learn the curve. So flow versus delta P curve will be there. So if you want to measure 10 ton per hour, then there will be strict amount of delta P, fixed amount of delta P only to generate the 10 ton per hour flow in the transmitters. So here delta P is fixed. Then why beta is also fixed. So now we are going to learn second topic, pressure drop because of orifice plate, and this is the very important. This is connected to the process people So we have to take care. See, this is the orifice plate. This is the orifice plate. Here we are installed here. So here some pressure is there, P1 is there, and because of this then P2 is created, and after this pressure loss here, some pressure loss has happened here, and this we are gained this pressure loss, we are gaining this pressure loss, but some places we are not unable to gain 100% pressure here. Suppose there is a 70 kg pressure, and here we got 1 kg or 2 kg 3 kg drop here in pressure, a 4 kg drop in the pressure, then we are not able to get exact 70 kg pressure after this orifice plate. So there will be a small drop, we are not able to gain 100% pressure here like P1. So this is called the pressure loss. So there is a limit, there will be limit, allowable limit. Beyond that, we process people will not accept the pressure loss. So they will give up to the upstream pressure. So this place is the upstream pressure, and this is the downstream pressure. So we are not able to recover. P1 never be equal to the P2. So whatever loss will happen, that will be represented here the P3. Part of pressure being lost, this loss is called as a pressure loss. Permanent pressure loss PPL is P1 minus P3.